Everybody. Thank you for joining. Um, Welcome to another great green energy series. Today's topic is going to be about affordable home batteries, and I'm so excited to share the expanding list of affordable home batteries that I've found. And I don't intend to, this is not going to be an exhaustive list. I'm sure there's more beyond the ones I'm going to show you in this webinar, but I think this is a good start, and you can continue to do your research on affordable home batteries from the resources that I share in this webinar. So, a little bit about Solar Oregon for those who don't know. Solar Oregon is a nonprofit that has been founded way back in 1979, way back when solar was significantly less prevalent and significantly less affordable than it is today. It grew out of a green grassroots efforts to support this clean, renewable energy resource. And we continue this mission to date by being a bold voice and trusted educational resource to empower all individuals and communities statewide to adopt solar energy. We do this by offering many webinars and events throughout the year, including many offerings of two webinars. One is the Solar Plus Storage webinar, which is our introduction presentation to people to familiarize people with how to navigate getting solar. And then the other webinar that gets repeated multiple times a year is a comparing solar quotes webinar. And that webinar, we give examples of solar quotes and then also give ample opportunities for the audience to ask Solar Oregon staff specific questions about their solar quotes that they've brought with them. And we do both of these presentations multiple times throughout the year in both virtual webinars and at in-person events at different locations throughout the state of Oregon. And then we also do deep dives into specific topics through the Green Energy series, such as this one on uh, affordable home batteries. We also do in-person events, like we organize home tours through the Go Zero Home Tour that's later this year. Stay tuned for information about the Go Zero Home Tour. The Go Zero Home Tour not only showcases homes that have solar, but typically it's homes that have uh, achieved either net zero or on their path to net zero. So we're talking about homes that have made significant strides to make their home more energy efficient, airtight, more insulated, and increasingly, many of these homes also feature batteries for resiliency. And increasingly, I want to talk about something called energy arbitrage. And later in this webinar, I'll describe that in more in detail. We also organize tours of farms that have installed solar via the Solar Winery Tour. This photo is of a winery we visited this year. As you can see, it's got solar on its rooftop. One of the interesting things about solar and its nexus with wineries and agriculture is that many wineries have a period of very high energy usage during their harvest and production period. But then in outside of that harvest and production period, their energy usage is very low. And so through net metering, then these businesses can collect net metering credits throughout the year and then use those net metering credits to offset their high energy bills during their harvest period and yield significant energy savings and cost savings to their business. But there's also farms that do agrivoltaics where they use bifacial panels to provide shade for their plants. And farms they used agrivoltaics in this way have found that not only do the plants grow just as well and sometimes even better in partial shade, but also that they gain the revenue from the energy generation, but also the water savings from shading their plants with these bifacial panels. And so there's a lot of great nexuses with solar and agriculture and wine growing, and we get to tour more and more businesses that have done this integration with solar with their agricultural business. And we visit new sites every year, and new sites come online each year. And with that, I want to keep going. If you like our work that we do at Solar Oregon, you can visit this link to support us. And we encourage you to use the Q&A and chat features to ask questions. A little bit about me. My name is Edward Louie. During my day job, I work at Pacific Northwest National Laboratory, where I get to do research on building energy efficiency technologies. Recently, my research projects include heat pump water heaters, heat pumps, and this year I'm doing research on dual fuel heat pumps and specifically some of the interesting things that arise with dual fuel heat pumps related to thermostats and how thermostats control the transition from heat pump to natural gas furnaces and back to heat pump, and how all that works in reality. So that's one of my research projects. I post frequently on LinkedIn. You can find me on LinkedIn. I have an off-grid net zero tiny house on wheels that I work on and continue to make additional additions and improvements to that project. And before we get going, I want to do a disclaimer, which is that the views in this presentation don't necessarily reflect the position of Pacific Northwest National Lab, the U.S. Department of Energy, or Solar Oregon. And I've made best efforts to convey facts and information accurately. However, I encourage you to do your own research and do your own calculations before making investment decisions. So with that, we're going to get into the topic of this week's presentation, which is more and more affordable home battery options. We're going to explore those options. Before we get into those options, we want to maybe take a step backwards and ask the question, why even get a battery, especially in Oregon, where we still have retail net metering, which is very good. I hope that that stays a policy that remains in place for in future years. But even with net metering, why get a battery? Two things is resiliency to power outages, and then the other thing is energy cost arbitrage is something I want to talk to you more about. And in the affordable home batteries, there's some other additional kind of topics with what there are products out there that integrate the inverter and the battery together into one product. And then the ones that the affordable battery options are typically ones where the inverter and battery are separate components, and there's advantages to that, and I'll talk to you more about that. And then if they're separate items, the inverter and battery, then is there inverter battery compatibility issues or not? We'll talk about that in more great detail. And then if you buy an inverter, since it's a separate box, then what features to look for, and then some examples of these all-in-one hybrid inverters. And then as you explore different affordable battery options out on the market, some safety certifications to keep an eye on, and whether, if that's important or not to have these safety certifications. I'll talk about whether it's important or not, and then we'll end with some conclusions. So one is resilience to the power outage. Even if you have solar on your roof, just because you have solar and inverter on your roof does not make your home resilient to power outages. In fact, the standard inverter, the rooftop solar inverter, is designed to not push power back to the grid. It's a safety requirement in order to ensure that when the power is out and maintenance people are trying to restore power, that they don't get shocked by electricity being backfed from your rooftop solar system. And so it actually, you have to specify specific inverter setups that have the proper what's called islanding or automatic transfer switches to be able to have electricity within your house when the power goes out. Um, Typically, many homes that don't have rooftop solar, they use a generator to be able to have backup power during an outage. And these generators, again, the generator itself cannot just be installed willy-nilly. There's transfer switches to, again, be able to island usually a sub-panel worth of loads. And so this switch can be a manual transfer switch or it can be an automatic transfer switch. But these generators, they have maintenance. because they have a combustion engine. So that means you're talking about oil changes, oil filters, air filters, a starting battery. You have to check all those connections, whether it's if you're using propane or natural gas. For gas leaks on those lines. And this annual maintenance, if you don't do this annual maintenance, you might find that the starting battery has gone dead. And so then when you do have a power outage and you're hoping your backup generator will start, well, it doesn't start because the starting battery is dead. So it's important to have annual maintenance if you're going to get this type of generator. But one of the advantages to a battery and inverter based um, backup power system is that you don't need to do any of this maintenance. There is no oil, there's no air filter, there's no starting battery to deal with. So um, there's quite a few advantages to having a battery-based backup power system rather than one that uses natural gas or propane or some sort of liquid fuel. And then, as we'll see in this price point here, about $5,000, you can really be cost neutral later when I show you some of the cost of the inverters and the batteries to a standby generator. So cost wise, it's people used to think, well, this is the cheaper option is to get, the natural gas or propane whole house standby generator. But the cost of the inverters and the cost of the batteries have come down quite a bit so that now it's quite competitive. Another concept to think about is energy cost arbitrage, which is the concept of, okay, well, if we have time of use, currently time of use in both Portland General Electric and Pacific Power is a opt-in rate tariff. So, your default rate tariff is a standard, same price throughout the day, every day rate tariff, but you can opt into what's called time of day or time of use rate tariff. If you don't have solar and you just have an inverter plus batteries, like those systems that I will show in this slide deck, you could, in theory, program it to charge the batteries in the off-peak period and then self-consume, program the inverter and batteries to self-consume during the mid-peak and on-peak, and then therefore be able to enjoy 9 cents a kilowatt hour electricity all the hours a day from Sunday to Saturday. So you could do that, and the payback periods are not terrible. Currently, it's not amazing either because despite the 9 cents currently, like if you have a standard rate tariff, it's about 18 or 19 cents. That price difference of 9 cents to compete with thousands of dollars in upfront investment, it still takes the last time I calculated, it's about 10 to 14 years, depending on the what upfront cost you consider. But 10 to 15 years, let's say. So it's kind of a long time, but in the future, the cost of electricity might continue to rise. And in other markets, the cost delta between off-peak and on-peak is much more severe, and their on-peak period is much longer. So, like, I can think of I think New York has certain regions that have much more of a stark contrast. I think Massachusetts also has some areas that have really stark contrast that make it to do this energy cost arbitrage to be much shorter payback period. But here in Portland General Electric and Pacific Power territory, it takes still a while. But hey, if you're trying to balance both the advantages of the resilience to power outage, and then this is considered like an additional benefit, then hey, that's really like a really, really nice cherry on top type of logic if you think about it that way. So diving into some examples of example affordable home batteries. The thing to note is those red boxes or this dollar per kilowatt hour. that's all you really need to care about is dollar per kilowatt hour, as being one of the major driving metrics. Um, but some other things to think about is like form factor. So like how are the batteries packaged? Like for example, this one is packaged in an enclosure that you can mount on the exterior wall. So if you don't have a garage or a basement where you can put the batteries so that it's protected from weather, and you absolutely need to put the batteries outside, then the number of choices you have for affordable batteries is much more limited because there's not out of the like let's say like 10 options that I know of, maybe only four of them are able to be installed outside. And so that's something to think about. Typically, if you have a battery that needs to be weatherproofed in an enclosure that can be placed outside, it is slightly more expensive. But these batteries that, for example, this one right here, $218 per kilowatt hour is still significantly cheaper than major offerings from like Tesla and Franklin and Enphase, etc. But this is not the only one. Let's look at another one. So if you want an indoor mounted battery, so this one is just in a less robust enclosure, so it's a little bit cheaper. So we're going from 218 a kilowatt hour down to 212. Okay, let's keep going. Here's another one right here by a different brand. This one is now 206, and then there's it keeps going down from there. It's um, if you want some battery option where you have to do a lot more, um, build it together, then it can be even cheaper. Like this one's $156 a kilowatt hour. I've installed one of these, and one thing I like about this type of battery is that the individual rack mounted batteries is still at a weight that's manageable. It's still kind of heavy, but it's manageable. But if you, for example, these 16 kilowatt hour batteries is equivalent to three of these 5.12 kilowatt hour batteries, three of them together. And so then the weight is also three of them together in one unit. So you have to figure out how to navigate getting this battery from its shipping crate to where you need it to go. As you see, most of them come with casters to help you maneuver it. Those that don't come with casters, the expectation is that you get like a electric assisted forklift or a hand truck that has a electric assist, or at least a crank assist, something like that, so you'll be able to help move this to where you want needed to go. You might need to rent some, like a electric or battery powered fork hand truck to be able to help move these batteries because like a 16 kilowatt battery is somewhere in the neighborhood of, I think it's like 200 pounds, maybe 300 pounds. So like it's kind of something to a bear to manage versus like a 5 kilowatt hour server rack battery. Each of these modules is somewhere in like the 60-pound range. So like, 60 pounds, it's not light, but it's something that a single person can manage. And then obviously when you stick them all into a rack where a rack holds six of them, then now it becomes a weight that you don't really want to move around anymore. So that's something to consider. Um, so another thing to consider is these UL certifications. So these are safety certifications that independently tested, laboratory tested for various components of battery safety. If the battery has these UL certifications, they typically are the manufacturer will advertise it quite strongly. So you'll find it either directly on the listing or when you scroll down on that page, it will show up. And if you have to dig for it or you can't find it, then likely it doesn't have the certification. Later in the presentation, we'll discuss whether this is super important or not. Um, Here's another one. Again, this one is basically 16 kilowatt hours. So it's three of these batteries packaged together. at a fantastic price of, again, 156 kilowatt hour. Um, these most of these ones so far I've shown you have UL certifications, but if you want to forego UL certifications, this is one that I keep an eye on all the time because it is getting really, really close to that $100 a kilowatt hour number, which is like unheard of in the past. And it's a a brand that has been well reviewed by many people and like DIY solar power forums online. It's not an unknown battery. It's been tested by the many prominent like YouTube uh, solar and battery testers. Um, so it's pretty good from what I've seen and read, but it does not have UL certifications. Whether you can get a battery like this permitted or not, I'm not sure. But it is a fantastic price and it does perform very well from what I've seen. And so all these batteries that I've talked about do not come with an inverter built in, so you need to pick a inverter to combine with that battery. But one of the great benefits of having a separate inverter and battery is that you can choose how much inverter you want versus how much batteries you want, and you can even mix and match batteries from different brands together. Um, there's we'll talk about, this concept of open loop communication versus closed loop communication and how all that works. But the conclusion is like, okay, well, if you want guaranteed compatibility in closed loop, then it's best to pick an inverter that the inverter manufacturer sanctions that battery, or that battery manufacturer has sanctioned that brand of inverter. If you don't pick one that is sanctioned by one or the other, then likely it will still work, but you won't be able to do closed loop communication. Um, and how important is closed loop communication? Eh, it's sort of important and sort of not, depending on what you want to do with it. Um, we'll talk about that some more. But the main thing is that as you expand batteries in the future, like let's say batteries get like even cheaper in the future, and you want to then buy some more to be able to, have additional hours of backup for your home. If you can add those additional batteries without really adding much more cost because you're not needing to add more inverters versus like something like a Tesla Powerwall 3. Each Tesla Powerwall 3 comes with its own inverter, and so each time you buy another Tesla Powerwall 3, you're buying both additional batteries but additional inverter capacity as well. Um, and so with the batteries that we're all talking about are 48 volt low voltage batteries, and so they actually have a nominal 48 volt is like a nominal voltage. If you actually measure it, it's like 51 to 54 volts. But anyways, it's a low voltage, um, meaning that it's fairly safe. Like, if you were to accidentally like touch one of these terminals with your finger, it will not shock you. So that's nice. It makes it easy for um, someone who's like more, it's a little bit more DIY friendly if you want to actually DIY something like this. Um, and it's not super complicated. The inverters that I'm going to talk about, these are most of these are what's called all-in-one hybrid inverters, meaning they have like specific lugs that are well labeled for where the battery terminals land and where your grid power lands, and it does make it quite easy to do the installation. But anyways, on battery and inverter compatibility, so most inverters have a quite a long list of battery protocols or that they are compatible with. And so if your battery is on the list, then typically that means that they can do closed loop communication. Closed loop communication means that the inverter knows very precisely the state of charge of the battery temperature, the number of amps that the battery is, discharging or charging, and the state of charge of every single one of the batteries. So, like in this picture, some of these pictures, there's 6 or 9 or 12 batteries. So instead of the inverter only kind of knowing the average power of the entire battery bank, it knows the power and voltage of every single individual battery in that entire rack. That's what you gain with um, closed loop communication. And so then what happens is that the you can get like if you want a dashboard to be able to see the state of charge for all the batteries in one dashboard on top of the information about how much the inverter is actually outputting and how much power is coming from the grid or how much power it's being sent out to the grid. You can see it in one dashboard. Uh, if you don't really care about, the dashboard and seeing all this stuff in one screen, you can always do the open loop option where the inverter really doesn't know what's going on with the battery. What happens is that like you can set the inverter to charge the batteries to a certain voltage and then stop charging. And the other thing is that each battery also individually has a what's called battery management system or BMS. And so if like for example, like if the top battery in that rack is a little bit more full than the other five on the rack, then you can it'll keep charging, and then the bottom uh, five batteries, for example, will you know shut itself off and say, "Hey, I'm full already," because the battery management computer within the battery says I'm full, and then the top one will keep charging. And so it's not detrimental. There's no way that you can like overcharge these batteries or undercharge them. Like for example, if the inverter wants to like keep discharging and discharging, like let's say you have a very cold winter day and you have a power outage, and it's very long, and so you keep using the batteries until they're completely out. You're never going to be able to like discharge the batteries to the point that it damages the battery because again, the battery management system will basically after a certain voltage, it'll shut itself off and so that the inverter cannot draw more energy out of that battery. So even though that there's not necessarily if you do an open loop system and you don't have that communication, you can still make it work and it's still safe. Um, where you absolutely do need to have closed loop communication is if you want to do things like, okay, well, I want to, on a average day when I am still connected to the grid, I want to be able to arbitrage and use like 70% of the battery state of charge. And but then afterwards, then if it discharges to, 30%, then I want the inverter to then hop back onto the grid and then use power from the grid to power the house, leaving that remaining 30% state of charge for in case that an unexpected power outage comes around, and then therefore then the inverter will then be able to use that remaining 30%. Or let's say it's not 70% you want 50-50. If you want to be able to do these types of, protocols, then absolutely you need to have that closed loop communication in order to set these very precise percentage, thresholds for be able to do that logic. But if you don't care about that type of logic, then open loop is totally fine. So, as I alluded to, inverter features, um, one of the things that come with being able to, for example, do zero export is and self-consumption. So, like, if you're going to have, a time of use rate where you charge overnight at the low peak period and then self-consume, then the inverter needs to be able to do that. And how the inverter does that is it has current transducers that are on the main power wires coming from the electric meter, and then it will then sense which direction the current is going, whether it's the current's coming in or the current's going out, and then it will basically adjust how much inverter capacity that it's going to produce on a second by second resolution, and then be able to basically make it so that the number of amps going out and in is zero. And so then that results in that self-consumption zero export mode. It also, if you want to be able to have electricity when during a power outage, you need to be able to island your home so that you're not feeding power out unexpectedly into the grid when it's being repaired. That means you need to have a transfer switch or transfer relay, and not the deep most inverters that you buy for rooftop solar, they don't come with this transfer relay. And so you need to find one that does, and these all-in-one hybrid inverters, typically they come with one, but you also then need to, on top of that, if you want to back up your whole house and not do a sub panel, um, then you need that transfer relay to be able to handle 200 amps, which is the typical main amperage or power feed that most homes have from the grid. One of the nice things about a 200 amp transfer relay is that you don't have to have the cost of an electrician to add a sub panel and then the added labor and a challenge of moving circuits around in order to figure out, okay, which circuits should we put into the sub panel that's backed up versus ones to keep on the main panel. So these all-in-one inverters that can back up the whole home, it may cost the inverter might cost a little bit more compared to one that doesn't have this 200 amp transfer relay, but the additional cost on the hardware side, you're going to save on the labor side for sure. Because I can tell you that in an existing home, trying to move circuits to a sub panel is not exactly a trivial task. Um, And then some additional features to these inverters is they do have a generator port. So in addition to be able to just switch from the grid, you can also hook up a generator, and they can typically then, send a signal to turn on the generator. So you can do things like, okay, well, I have 16 kilowatt hours of battery. And then when I exhaust that or come close to exhausting that 16 kilowatt hours of battery and the power is still out, then, I want the inverter to then send a signal to the backup generator to turn on and then continue to back up the house in island mode until this extended power outage, comes back online. It can do those features as well. In addition, they typically have more than one solar inputs or MPPT inputs. Um, that means you can like have your west facing solar and your east facing solar panels on different MPPTs to be able to maintain efficiency. But typically they have two, three, four MPPTs so that you have more than you need. Perhaps in the future, more and more cars might, if they do vehicle to home, there may be a way to be able to actually use one of those MPPTs for officially supported by the automotive manufacturers as like a way to be able to input high voltage DC from your car into the one of the MPPTs of a solar inverter. So having spare MPPTs is also a very good thing. So here are some example all-in-one hybrid inverters. There's the list is not exhaustive, okay? But at the same time, the list is not hundreds deep either. Um, I've looked and looked. I think there's maybe 10, maybe 12 inverters out there that can have all the features like this 200 amp transfer switch, be able to do 48 volts input to batteries, and be able to have the current transducers to be able to do zero export. When you add all those features together, I think the list is somewhere around 10 to 12. But the brands that I know of are SolarArc, EG4, Ruxu, SunGold, Linotech, and Lux PowerTech. Um, and EG4, for example, I think is made by Lux PowerTech, so the number of OEMs is maybe even smaller than that list. Um, so these inverters, you back in maybe 2, 3 years ago, you expect to pay around $5,000 from these inverters. But now with the list of manufacturers getting a little longer, the new price point is somewhere around 3,000 or a little bit less than 3,000. So like Ruxu makes one that's you can easily get for under 3,000. Linotech, you can get that one for a little bit under 3,000. Um, and then this one from SunGold, you can also get that one for a little bit less than 3,000 usually. So, and then this, in the question is like, okay, well, if I pay $3,000 instead of 5,000, do I get like less for my, because I'm paying less? Um, I think maybe you're getting less support to, after sales tech support. Like I think, from what I've read, EG4 is a pretty good tech support because their tech support's out in Texas. But if you get a Ruxu inverter, you're trying to do tech support for someone in China and just the time zone difference could be quite challenging. Um, I don't have any experience with Linotech or SunGold, so I'm not sure. But as far as on paper features, they are very similar. So like, this new price point, you're not getting less features on paper versus the like 5,000 and then SolarArc is usually well over 5,000. SolarArc all-in-one inverter is probably like 55 or even $6,500 for a comparable sized inverter. Okay, so on safety features, that these are different testing requirements or protocols that US-based safety testing protocols for batteries. UL 1973 is, I guess, the most basic if there's a list of UL requirements, the minimum is to achieve it would be UL 1973, which is testing at the cell level whether the battery can handle being overcharged. Are there circuitries and battery management systems to prevent overcharging? And if that battery management system were to fail, will it cause, a domino effect and lead the battery to explode? Um, which is why I think most of the battery manufacturers have all moved to lithium iron phosphate and possibly moving in the future, it might be sodium ion battery chemistries because these chemistries are much more inherently safe than NMC and lithium ion chemistries of the past. Those are quite dangerous um, if the safety circuitry doesn't work properly. But in addition to electrical safety, there's also in this test standard test for mechanical safety, like if you were to drop the battery, it's subjected to vibration or, you know, especially those outdoor batteries, like under extreme heat or extreme cold, is the battery going to do um, unexpected things? This UL test will test the battery to ensure that there's safety within the designed parameters and then under unexpected conditions. All right. So 9540A is specifically a not necessarily a test standard, but a test procedure to try to see what happens when you try to induce a thermal runaway. So both by like either damaging the cell for this case, like if it gets punctured with a nail, what happens to the battery? Does it, you know, uh, vent a lot of gas? And is that gas going to be a problem, or is it going to explode? In this case, this is a lithium prismatic lithium iron phosphate cell, this test is showing that hey, even if you put a nail through it, it does not do anything crazy. And then another test that's done is okay, well, what happens if, there's some sort of heat source next to the battery and it heats up the battery to, past its safe conditions? Will it cause the battery to explode? Will it cause cascading failures? And if it doesn't, then that you're not required to move to subsequent tests. So if there's inherent safety at the cell level, then there's not necessarily a requirement to then do further testing at the module or unit level test. But if it's not super safe at the cell level, then they'll advance to module level safety. So like, okay, well, if one cell actually does vent gas, does that gas then cause the cells next to it to also vent? Will it create a domino effect? And if it doesn't, then maybe it's inherently safe at the module level. So 9540A does that kind of testing. And then UL 9540 is a system level certificate where so this in order to get this certificate, you basically have to have a list of all the combinations. So because like for example, with a battery and an inverter being a separate component, then you have to have a each combination be tested and then certified. And so therefore, if you buy batteries and inverters from different brands, it's unlikely you're going to be able to get a 9540 UL 9540 certification. Whereas if you buy the battery and inverter from the same brand, then there's a good chance that you can find a combination that has been UL 9540 certified. Um, to what extent is this really required? Um, I think like if the batteries have been tested to be safe, from overcharging, from damage to even if you puncture with a nail and it's still safe, um, then it doesn't really matter whether it's overcharged by one inverter versus another. It's still safe because the battery management computer system is properly managing the battery internally. Then, eh, like it, I don't know. It depends on whether your AHJ requires a UL 9540 certification. If it doesn't, you might have a lot more freedom to choose an inverter and a battery that isn't um, matched and independently certified. And so, what do you gain from, having all these new options? You gain um, potential, like compared to a Tesla Powerwall 3, you gain like 2.2 times the battery capacity for $1,000 less cost. So, there's pretty significant savings to be had for buying batteries where you have to kind of put it together with an inverter. Um, and in this case, like um, the inverter in, and you can even find ones like, for example, like Ruxu, they make batteries and they make inverters, and you buy the same brand, it probably is UL 9540 certified. And so in terms of safety certifications, it's comparable to, some of the name brand offerings from Tesla, Franklin, Enphase, etc. And so, these new offerings get you a lot more battery capacity for the same cost, or you get to have the option of um, the same capacity as a Tesla for a fraction of the cost, depending on how you look at it. Um, so with that, I before I answer questions, I do want to put a plug on upcoming Solar Oregon events. You can find them on Eventbrite. So you search on Google like Solar Oregon Eventbrite. It's the first listing that comes up, and then if you click on that listing, you'll get to see all the upcoming webinars and events that we have posted. And with that, I do want to jump into questions. I think there's quite a few. Let's see. Lower cost batteries, just as reliable and effective. Listed specs. Um, yeah, so most of the lower priced batteries have been tested by an independent um, uh, person. The one person that comes to mind is Will Prouse. He runs a pretty famous and well-known YouTube channel, and he tests a lot of batteries. Um, and most of these lower priced batteries he's tested quite robustly and found them to meet their specs and be reliable. Some of what you're describing with the inverter sounds similar to the features described for a smart panel like SPAN. Are they doing the same thing? Does an inverter take on some of what SPAN would be doing? Um, there are inverters so EG4 makes a Flex Boss and Grid Boss. So the Grid Boss has smart circuit breaker um, on that product, and those smart circuit breakers would do some of what SPAN is doing to be able to do circuit level load shedding and load prioritization. So, and the EG4 Grid Boss and Flex Boss, how that works is that the Grid Boss contains the 200 amp automatic transfer switch, and that enables one to buy if you need like two or three inverters in order to meet your home's peak load, then you would buy two or three inverters, but then you don't necessarily need to buy two or three transfer switches. So a lot of the other options I showed in those slides have the automatic transfer switch built into each inverter, and so therefore, if you need two inverters, you're inadvertently paying for that transfer automatic transfer switch twice. But with the EG4 FlexBoss and GridBoss product, then you can buy like two FlexBoss inverters and still only buy one GridBoss to kind of control those two FlexBoss inverters. And then not only do you get separate that automatic transfer is separate, you also get the smart circuit breakers in that Grid Boss product. But that's a fairly unique product. I don't know of any other manufacturer currently making something similar like that. So maybe for now, that's like there's a one brand to go for that product. Okay. If you don't have solar, do you just initiate when the battery is charged, kind of like phone or something like that? Correct. Yes. So when you start up a inverter battery only system, uh, you will be charging those batteries using grid power, and then you can set up the inverter to discharge or self-consume at certain times of the day, or you can have it so that it's just fully a backup option, and therefore it does not discharge unless the grid is sensed to be out, and then automatically switches like a computer uninterruptible power supply. Then also another good thing about inverter-based battery inverter-based backup power is that the transfer times is like usually 10 or 20 milliseconds versus if you have a Generac or any sort of engine-based transfers, that usually takes 30 seconds, a minute to be able to transfer because you need time for the engine to spin up in order to then transfer. So if you really want a backup system where you have no idea that you've switched over to backup power because like the lights don't even flicker, um, a battery inverter based system is pretty awesome. Okay, when you purchase solar and batteries from a contractor, do they install the battery for you? Uh, I guess yeah, I think what you're trying to get at is if you purchase the solar and batteries from maybe the different sources, like for example, Signature Solar or some other place where you can actually buy these fantastically priced batteries, can you find a contractor to install them for you? Um, I I've heard of like one or two contractors in town that will install a battery and inverter that they did not supply themselves. Um, the my friend who did that, I saw the quotes and that contractor charged kind of a high price for doing that install, maybe to account for the fact that they didn't make any profits off of the upcharging. They didn't put any profit into the parts because you supplied the parts for that project. Um, as far as contractors that are willing to sell some of these fantastically priced inverters and batteries, um, I don't know of any contractor in town that will sell you one of these fantastically priced batteries or inverters. Most contractors are quite conservative. They don't want to be the first to do anything. So like that's why most contractors want to install like a Tesla or a Franklin or a Enphase battery because those are been tried and true, and many other contractors before them have installed these batteries and have success with them. So yeah, I don't think you're going to be able to purchase these batteries through a contractor. You're going to have to purchase them yourself and then find a contractor willing to install them. Either that or if you're a very savvy DIYer, um, almost every single AHJ in the state of Oregon will let homeowners do work on their own home legally. It's totally allowed for homeowners to work on their own home. So if you are a savvy DIYer, you can, um, you know, do it yourself and apply for the permits. The permits aren't that expensive. And then I know almost all the power companies will work with you. So, like, if you don't have a 200 amp, um, what's it called? A circuit breaker between the meter sockets and the main circuit breaker panel, and therefore, in order to work safely, you need that meter pulled from the meter socket. All the electrical utilities will, if you give them a call, then within 24 hours, they'll send someone out to, snip their uh, one-time use tag, and then be able to pull the meter for you out of the socket. And then when you're ready with, re-energizing, they'll come again and stick the meter back inside the socket. Um, some power companies have a smart meter. They can actually de-energize by remotely using the what's it called? Smart meter capabilities. So that's also another option. Obviously, if you're going to install this stuff yourself, like you better have at least a pair of insulated electrical gloves because we're talking about working with the main wires coming from the meter. So 200 amps, 120 240 split phase. So it's a lot of amps and a lot of power. So like you got to know what you're doing if you're going to do this stuff. But otherwise, if you're not comfortable doing stuff like that, you should hire an electrician. Okay. See any other questions coming up? And check the chat also. Uh, Chat looks clear. All right. We'll give people another few minutes. Um, and then also, if anybody wants to go through any of these slides, this webinar is going to be recorded and post onto the YouTube Solar Oregon YouTube channel in about a week's time. So if you want to go back and look at specific model numbers. You can look at the recording and then see the model number and then continue to do research on your own. Um, I've had a great experience with some of these batteries and inverters, um, and I definitely would not hesitate to recommend someone pursue this path of going with one of these batteries or one of these inverters. Okay, well, with that, we are nearing the top of the hour, so we'll call it quits. And I look forward to seeing some of you guys at the next Green Energy Series. And keep an eye on that Solar Oregon Eventbrite for that listing when it pops up. All right, take care, everybody.